Hello everyone, welcome to my channel. I've started a personal DSA challenge where I'm solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on the problem name Best Time to Buy and Sell Stocks. So the problem states that we are given an array prices where each element is the price of the given stock on that particular day. We need to choose a day to buy one stock and choose a future date to sell that particular stock. If you cannot achieve any profit, we will straight away return 0, and we also need to achieve this only in one transaction. So the key observations here are: we must buy before we sell, and we are allowed only one transaction. So the most straightforward approach would be we'll be trying all the possible pairs of buy and sell days, and for each day we will be checking all the future dates to calculate the profit. So for that we would need a variable max profit to track the maximum profit, and we'll initialize it with 0, because if there is no profit then we would return 0. So for now let's initialize it with 0, and we would iterate through the given array. This for loop is to buy the stock, and the second for loop is to sell the stock. So for that we would start iterating from I+1, because we should sell only on the future dates. And we would iterate till the end. Now we would initialize one more variable called profit to find the difference between the buy date and the sell date. So the sell date would be the sell date and the buy date. So the sell date would be prices of J and the buy date would be prices of I. That's how we get the profit, and we need to update our max profit variable. And the current profit, and at the end let's return the max profit. Let's run the code. It is working. So this requires two nested loops, so it is leading to a time complexity of O of n square, and we did not use any extra space, so the time space complexity would be linear. This code works for smaller inputs, but this does not scale well for larger arrays. So for that we need to find an optimized approach wherein we have to find the maximum profit in a single pass. So for that we can keep track of the minimum price that we found so far, and we need to calculate the maximum profit that we can achieve. So we need a new variable called minimum price, and let's initialize it with the maximum value, and let's iterate through the given array. So this price would be the current price. If this current price is less than the already assumed minimum price, then we have to update the minimum price variable. So if this price is less than the minimum price, then we need to update minimum price with price. If it is greater, then we need to update the maximum profit variable. Max profit and the current profit. the current profit would be the current price minus the minimum price. And at the end we will return max profit. Let's run the code. It is working, so let's submit it. And it is accepted. So instead of checking all the pairs, what we did, we are tracking the lowest price which is seen so far and also the maximum profit which we achieved so far. And this also covers one more edge case wherein if we do not achieve any profit, we have to return 0. So if we do not achieve any profit, we would return the maximum profit which is already initialized with 0. So this case is also taken care. So this problem shows how we can optimize the brute force solution by avoiding the repeated comparisons, just like how we did in this loop. Let's take an example and let's dry run the code for the given input. So if the current price is 7, for example, if the current price is 7, if the current price 7 is less than the maximum, okay, it is less, so initially the minimum price would be 7 and the maximum profit would be, maximum profit is already 0 and the current price minus minimum price, 7 minus 7 would be 0. And then in the next iteration we would pass 1 is less than 7, so the minimum price would be updated to 1 and the maximum profit would be max profit of 0 and the current price is 1 minus 1, which is 0. Okay, in the next iteration we go to 5 is not less than 1, so we will not update the minimum price and the maximum price would be the current price 5 minus minimum price 1, which is 4. And in the next iteration we'll be going to 3 and 3 is also greater than 1, that's why we'll not update this minimum price. It will go to the else block and here the profit would be current price is 3 minus minimum price 2, so the max of 4 and 2 would be 4, so we will not be updating. And in the next iteration we would be going to 6. 6 is also greater than 1, so we'll not update the minimum price. It will go to the else block and in the else block the current price 6 minus the minimum price, which is 1. 6 minus 1 is 5, so maximum of 4 and 5 is 5, so we would update maximum profit. And in the next iteration we'll go to 4. 4 is also greater than 1, so we will not update this and we'll go to the else block. And in the else block the current price 4 minus 5, which is minus 1, and the maximum is 5, so we'll not update it. So it will come out of the for loop and it will return the maximum profit, which is 5, and the expected output is also 5. So that's how we do this, and that's it for today's problem. In the next video we'll continue with container with most water using the same pattern. Thank you for watching.